Yeah. All everything in the screen are captured. Okay. So no, your talk, my talk.
Okay. So if we read the question, will it be recorded?
Yeah. So my topic today, the Lost CAPM, is also controversial. Not the topic just now. So I will run it short. Here I first present some questions because the CAPM was presented and relationship and static values. They are not stochastic relationships. Can we run the regression here? Y on S only given here mu means the expectation, static value. And if yes or not, what is the underlying data generating process for CAPM? Because CAPM is a relationship on unconditional mean, unconditional values. And then as a problem, is there any other factors? This is related to theory and empirical study. And then CAPM is undoubtedly a one-period model. Can we extend it to multi-period or using time series data? This was the practical job. But in final, speaking of the equilibrium, what are the difference between, say, goods and assets? For goods, the active variable are price. However, for assets, it is not price. It is a risk and return, not the price. And what are the difference in how to determine the demand for an asset? If we are speaking of an equilibrium, there are supply side, there are demand side, right? Yes, I've been studying on this issue for more than a dozen years, since I'm a PhD student 16 years ago. And now I have some source of preliminary results. And so this talk is critical and therefore provocative, I think. First, regression is a conditional expectation, as everyone of us has learned. For example, I speaking two cases. Here, that this is a stochastic relationship, and we give some assumptions here, conditional independent, and with some parameters value. So we had this conditional relationship. However, we had this one, right? Because the expression of S is 1 and Y is 6. So you can the combination of 1 plus 5 mu S. But if you run a regression, the coefficient and will be known with 5. The estimate. This is the first situation. And okay.
Why is the mean of 6? Why is the mean of 6 x is the mean of 1? Why do we have this? Why do we have this equation?
This one.
Yeah.
And this is true, right?
Mu is not the mean, right?
Mu is the expectation.
It's observation, right?
No. Here is the expectation. Expected value.
Expected value.
Yeah, expected value.
Why can't I have mu y equals 3 plus 3 mu x?
This one. And this is true, right?
I mean, I can write an equation, mu y equals 3 plus 3 mu x.
Yeah.
Is that true?
True. But this is also true, right? If you give me the relationship and static values, this is undoubtedly true.
Sure. This is also
We can use other combination. Say 2 plus 4 mu is also
There's
true.
an infinite number of
Because here the relationship is n static values, not a conditional mean, not a regression relationship. Right? Okay, another problem here is that endogeneity. So I'll skip. Suppose that there are covariance. Here, the covariance is not 0. So you cannot fit an regression because this or endogeneity is variable. And here, so we are what we know is relationship on accretion mean. So here, the underlying DGP is the top priority. What is the underlying relationship? Stochastic relationship. And first, a review of the market settings. The market settings says we had so many risky securities, and we had a risk-free asset with this gross return, and we assume the mean vector and the covariance matrix are stationary. And also I introduce some symbols, some notations. This is used for computer diversification, and here are assumptions. The price are positive, and there are some variations. The expectations are not equal. At least one I and Z are different. And the third, no redundant asset. The full range of the variance covariance matrix. And then this is the traditional way. Traditional way using the mean variance performance preference, and then mean variance, and you can find the optimal portfolio. And here I want to remind you that the optimal portfolio do not depend on the detailed function, only require the properties that increase in mean and decrease in variance, decreasing in variance. And is on the efficient frontier of this is frontier is of only risky assets, because here I mentioned the portfolio in the pure risky assets. And also it's easy to find the market portfolio here. This is the market value of all risky assets, and the market portfolio is summation of individuals. And it's widely known that here the market portfolio is at a tangent point of the efficient frontier of risky asset and efficient frontier with risky asset. So now comes my question. Market portfolio gives the demand in total values of each asset. They are not in price, they are on value of firms. And how to determine the supply of risky asset? And another question is that the market clear for the risk-free asset? Because many textbooks say so. Like so many textbooks like here. Like this one. This is the Imaging Pharma's book, Foundation of Finance and Theory of Finance. They also claim that in the CAPM framework, even the risk-free assets are clear. But this is not a story. Okay, now I'll investigate the DGP. And this is the first paper in investigating the CAPM by this one. BJS here. You can download from the from the SSIN. This is and their story, when they're going from the relationship of the static values to stochastic relationship to regression equation, they assume a market model. So they turn the relationship and static values to conditional mean. And I should remark that the market model was proposed to simplify the estimation of variance matrix. They are not a theory result, and its theory located. I'll show you below. Okay, here just now I'm talking about the traditional framework. Now I will use another framework called principle of non-arbitrage. In this framework, we have this relationship. Non-arbitrage and pricing function have the relationship of if and only if. Here, what is the pricing function? Pricing function is given the random payoff. Here, S, this one means the payoff space. And each payoff can be find the price. The price is a real number, right? So this is the map from payoff space to real number. And absence of arbitrage can divide into the following categories. First, they should pass the origin. 0 in, 0 out. If there is no output, no input, the price must be 0. And second, homogeneous, linear. Most of the time, people talking about this one. We call this law of one price, linear, linearity. And the last one is positivity. If the payoff is positive, if the payoff is positive, then the price must be positive. Means no free lunch, right? And okay, and using this arbitrage at level 3 only will imply here for any assets in the market, there is a unit in the market setting just now. There is a unit payoff here, and this is SDF, right? Stochastic discount factor. And I define this one. This one is a return because it's the payoff over price, so it is a return. And it's very known that this one is the minimum second moment return. Minimum second moment means, for example, in the mean variance space, not payoff space, mean variance. This is the mean, this is the variance. Then this one is the minimum second moment. And then we have this decomposition of returns. Here, I define another return. This return is an asset return. So what is the asset return? The asset return satisfies the property. The price of asset return is 0. Because the price of return is 1. And an asset return is the difference of two returns, right? An asset return is the difference of two returns. So the price must be 0. So in this space, we can define this projection. And you can find this theory, this one. Given every return, with given static return mu, then there is this decomposition. And this is not new. This you can read here by here. John Cochran's asset pricing and this one page. Here theorem is here. But I give you more detailed result because my market setting is is a concrete market setting. So this is a new result. No, it's not a new result. So here we have this decomposition, but this is not CAPM, right? And using the theorem just now, I can give you this decomposition. This decomposition for any asset of portfolio with return I, and decomposition to here RJ, RM, and here the residual. And here RJ is the mean variance, is on the mean variance frontier, and it's zero covariance with the market. And this is the data defined usual. So if you take the expectation, you will find here the traditional CAPM. Because in the traditional market CAPM, we have this one. There is coincidence. Here are some of my comments. And for it, we define here. And many textbooks, they said in CAPM, you will add something. Suppose this R. If you add something, the residual, they give you no economic meaning. However, here, using this decomposition, you will find the economic meaning here, the distance from the efficient frontier. So in CAPM, for any asset here, this part is the residual, according to this decomposition. We are not just add this residual to form the regression, but it has some theory, underlying theory. And here, the three components are not orthogonal. They are zero covariance. Here, the covariance is zero. But just now, using the pricing kernel, they're using the orthogonality. But here, they are zero covariance. And in this model, you find that this factor, I call it J factor. So it is not a DGP, in fact it's a decomposition. And I think the DGP should be determined by the production function of firms. Firms that issue the securities, right? And there is another factor, besides the market factor, there is the market neutral. This is market neutral. Because the covariance, all its beta is zero. Because what is the beta? Beta is the covariance of this asset in market over the variance of the market. The covariance is zero, the beta is zero. And just now I'm talking about the market model. When we are talking the market model, you just shift this RJ into the residual. And thus, as we know, this will lower the R square and string the T statistics. And furthermore, this is a survey paper. Survey maybe I don't mention 1,000 but hundreds of paper. And it point out that only about 4% of months data and 20% of if we're using annual data. So to explain this phenomenon, I think maybe this is stop, and this is the dominant factor. And this can be very dominant. Maybe this one. Suppose here the market is here, but the J factor is here. J here, M here. So this is the variance. So the variance of J factor, the market neutral factor, has a very big variance. So only if you're using mass data, only 4% was captured. And you can do this on pharmacy paper. Many pharmacy paper also share this phenomenon. And in fact, the J factor was mentioned. We can trace back to year 1972. Brad himself passed the paper here. He assumed no risk-free asset. And this one is a leading paper of JFE of 2014, a leading paper. But the theory, something was wrong with the paper. I had write a comment. And his OLG model, or lapping generation model, also lead to the zero beta CAPM. If you answer this paper is here. I upload it to here, the SSRN. And in my current paper, I'm working on another settings. Let R be the label array, and R0 be the TB array. And they are heterogeneous when vectors with two groups. One group, they are using label, and another group they are limited to only TB. This is true because institutional investors, they can use their label array, right? Using these settings, also lead to here. This is a stochastic relationship. They are not and B. They are random variables. And here you can find they are also a J factor. And note that under these three models, at this time, the expression of the J factor is not equal to risk-free rate because the market portfolio is above the tinging portfolio. Now I give you a numerical example. Here, this numerical example I use the traditional way because traditional way will give you some concrete results. Here I assume causative utility, and this is the endowment and with 4 investors, and each one has its utility, mean variance, causative mean variance. So I have these values, and the market setting is here. This is the expected return. Here are gross return. So you find 1.09 means 9%. And here is the sigma. It's fit to the market data. And for simplicity, I assume constant correlation, and the value is 0.1. With risk-free rate, this value 5%. And this gives us this result. The market, and here the market value, this one. As we shown, the total social values is this number. So the free asset is not clear. The risk-free asset is not clear. This is my numerical example. And if you want to compute, it's very easy. I think many of course use software, right? You just compute, and this is very convenient and easy to check. And for the investors, here this is the risk-free asset, and you find that here this is not clear. And furthermore, beta. This is known that beta is this definition: covariance of the return over variance of market returns. And I'll show you that we are discussing more on betas. Here, for normal or traditional settings, beta will equal this value. And which means for each beta, this one will be positive. Because the market here, the market portfolio is most time the market portfolio here J, here M is always above market neutral portfolio J. But this is a presentation. He also points out that more than 10 years, the stock market realizations are on average less than risk-free rate. You know, 1980s, the risk rate is 26% in US, right? So it's very, very high. The stock market does not overperform. So here, given the market settings, you find that higher expected return incurs higher market risk, not vice versa. Because here this is given, and then we compute beta, not the other way around. say here, given mu and v, the beta is being computed, is set. And here, I'll show you that beta is a function of the risk-free rate. Here, we had an analytic solution, closed form solution. So if the risk-free rate is changing, beta also changing. Here, suppose the risk-free rate drops to this value, you can find that beta here, n is greater than, here is greater than, right? Yeah. And this is another common. Using CAPM, consumption-based CAPM, we also had a beta representation. In fact, this beta is just now the R. You remember this one, R column. Is the mimicking portfolio return of the SDF, right? A mimicking portfolio return. Okay, now comes the cross section. Because most of the CAPM empirical study paper use cross section, they use two parts. The first part, time series. The second part, cross section. But how to understand cross section? Mu I are given. So if you want to explain the cross section, you must regard this one as the population. The random draw is mu I. Now come to the problems on time series. This one is this board. This board is also a traditional board here. This one. This one win the Samuelson prize, right? Here. So I'm taking from this page says a single period model do not have a time dimension, and to perform econometric analysis, we should add some assumptions. In the assumptions, IID or something I will just mention. The most important assumption is this one. While the assumption is strong, it has the benefit of being theoretical consistent with the CAPM. No. You use another assumption here. CAPM holding period by period. But here comes this question. Is it possible that CAPM hold period by period? In short, no. Here, there are many concerns. And 40 years ago, they lost. At each moment of time, the market portfolio is efficient. Hence, with no stochastic change in the underlying description of here expected returns, the same market portfolio will be chosen at all times, the same market portfolio. However, the price change. How can you maintain the same market portfolio? The market portfolio is a function of price, right? Suppose there are only two stocks. One goes up, one goes down. Then the market portfolio of the stock going down has a higher weight. And the other one has a lower weight. So the market portfolio is changing. This is inconsistent. And some proposed by conditioning. But conditioning. The problem is, as the random realization given that period, the current price produces the right market portfolio. This is a very, very complicated constraint. And this one, once I also discussed this with Ling, and still I get nowhere. Cannot find a solution. And there are more questions. Can we run a regression? Here, no. Not only the market factor, there are neither J factor in this theory. In two parts, also some problem. And those credits show that the bin variance efficiency of the market portfolio is equivalent to the CAPM. This is and where this is a mathematical result. So, again, the market portfolio. Market portfolio has many problems. I'll give it to you later. And the market portfolio is not unobservable. And those papers said the market portfolio is not observable because you include the real estate, the intangible asset. But here, in my settings, our asset only contains the pure risky asset and risk-free asset. So that is observable. However, the J factor and maybe a dominant factor is unobservable. It's a zero covariance of the market factor. So how to figure it out? If we want to carry a empirical study, now we are talking about financial market data. There are still other problems. Here, for example, suppose this is true. However, we have different growth of investors. Some for half a year, some for 2 years, some only 1 month. Different horizon. What will be the result? And because you will combine, this is the monthly data, and you combine into semi-annually, biannually, or monthly, there are some problems because the data are not independent. So the summation and the variance structure are complicated. And again, beta is a function of risk-free rate. And as we learn, risk-free rate is time varying, right? If other settings are not changed or stationary, the mean, the variance, the return are stationary. But this one is time varying, and beta will change. I showed you now from 5% to 4%, beta increase. And here, if R is stationary, the return are stationary. A buy and hold portfolio is not stationary. Why? Here. This is the return. This is the value of a T times 1. This is the first asset value. This is the second asset value, right? And a very simple example, let R1, R2 be normal. And this one is the return of the first period. However, for the second period, this one, because the weight are changing. Why weights are changing? Because the price are changed. So some go stronger, some becomes weak. And as we see, this one is this one. However, this one is that's not easy. This is called ratio of two normal. And also I checked this with Lin said this.
But what if you take low? If it is still stationary, take low
and tail is not it is not station because it's just summation here. Near just summation, right? And also, what is the unit? Unit summation EI equal U. U is unit. Summation still not. Each component is stationary, but however, your summation is like individual, right? So it's unit. It's still not stationary. Because you here summation is over I from T from 1 to T, tau from 1 to T. This summation is increasing, right?
RP2 may not be a ratio of two normal elements because the denominator may not be normal because it's the product of two normal random variables. That the product of two normal may
Oh, I see. First, you can compute the conditional beam. The conditional beam is the normal ratio. Yeah, and you can set other settings. And this is you can run a paper and statistics give you analysis of the normal ratio and something like this.
But if it's conditional on RP1, sorry, I don't understand. I'm just wondering if here is non-conditional explanation, right? If it's a
I see, I
conditional, know
see.
the P1 results. I guess the expectation of P2 conditional on knowing RP1 should. It's like we know that we want the already.
Okay, speaking of the Malonian motion, the conditional beam is stationary. Conditional because the increment is independent. However, if you consider the process, the full process is not stationary, right? So conditional, stationary, unconditional, or the full process is not conditional. Like the Brownian motion is a typical example. In SARS, the market portfolio is not stationary because the market portfolio is a buy and hold portfolio. And also here, Lost 1978 paper in the footnote, very smaller type. Without stationarity source or some explicit model for non-stationarity, economics itself is in jeopardy, and this seems too tragic to take serious. But this is unsolved now, and many academic papers just skip this part. So I jump to my conclusions. There are hundreds of papers theory and thousands empirically. But however, there are at least two factors. This is in theory, two factors. And second, and the last one, much undone in economics because even using the market data, you find many problems. And what I had done in some research is, okay, we can to grow with different risk rates, and also I can use arbitrage arguing and permanence seeking. What is permanence seeking? We know life is a business of uncertainty, so we seeking some life to be permanent. 就叫做生命是无常的，我们就喜欢，包括像消一样，我们希望我们消费是平稳的，所以呢，we seeking constant level or permanence. We also get the result of the CAPM with two factors, market factor and market risk neutral weight, market neutral weight. Okay, this is my talk.
Questions or comments? I still have some doubts about the ratio of two normal. The mean will not exist. Like you have, if you have two constants, right?
Okay, I'll show you.
Right.
You know what is the Cauchy distribution? Cauchy.
Cauchy, yes.
Cauchy S over Y and S and Y are independent, right?
Right.
If S and Y are not independent, the beam also not.
Not this. Yeah, I know. There's a Cauchy distribution. But what I said is that a constant is also a normal distribution, right? The variance is 0, has mean. So 2 over 5 is a normal divided by another normal, right? But it's still not a constant. Still normal.
Okay, Cauchy distribution S and Y are independent. S over Y is Cauchy, and the beam does not exist.
Right. I know.
If you follow these two are normal, this is called normal ratio.
So is there a theorem says that two normal random variable ratio will not be a normal? Is there such a theorem?
It's called normal ratio distribution.
Yes.
Like a Cauchy distribution is a special case of normal ratio, called normal ratio. Normal
But
or
is
not?
that all the normal ratio does not have a mean?
Yes.
There's
This is a class. Yeah, this is a paper. I can give it to you.
But
It
how do
published
you,
in 1930s.
but how do you consider my example like 2 over 5?
What is 2 over 5?
Number constant 2 divided by constant 5.
The numbers are not random variable, right?
But it's a special case of normal random variable, right?
It's a realization. It is not a random
No,
variable.
no. He's saying that the degenerate random variable that takes on the value 5 with probability 1.
Yeah, this
Calling
is
that a normal random variable, and that I'm not really clear on whether that's truly you would actually consider that. So also a uniform variable, perhaps. Why we're calling it? I mean, I'm not really sure that's what we understand by normal variable. But I thought the mean of the Cauchy distribution was 0.
what is the distribution of 0?
The mean
Mm.
of a Cauchy distributed random variable was 0.
No, the mean
Is it
doesn't
symmetric?
exist. The mean doesn't
It
exist.
was symmetric around 0. But the variance didn't exist.
The mean.
The mean didn't exist.
The mean of Cauchy doesn't exist.
Cauchy is a staircase of called normal ratio, Gaussian ratio.
Okay. I don't know this theorem. Maybe you're right.
Maybe I'm wrong, but it seems the Z factor is similar to a total factor for
Yeah, maybe we should connect, say, in general equilibrium framework. For this, you will find on CAPM, we only consider the demand side, not the supply side. And the demand and the CAPM are demand values of folds. So speaking on the price in CAPM, there are many medium. First, the price is the absolute value of the security price. And second, the price is the price of capital cost, called capital cost. In some papers discussing the price of the risk price. This risk price is similar to the cost of capital, but they may have some small difference.
Okay, let's think next time. Okay?